So today, I just called this an introduction to numbers. That's not really accurate as to what it is. But let's start with a little intro, okay? Making math more real. That sounds so street, but no, that's not what I'm talking about. All right. So I've been teaching for 16 years, and math and me obviously are connected. But as a teacher of math, I often have students who say to me things like, I hate math, and math is so hard, and why do we have to learn this? I hear it all the time, so it's not the first time I've heard that sometimes. So I often argue back, like most math teachers would say, well, no, you have to learn math. Why? And then I would make arguments, and I'd say, maybe you're disconnected. Maybe you don't think that what you're learning in math class is ever going to be real for you. And in some cases, you might be right. What you learn in math class may not be real for you. Okay? Now, I could make the argument, well, and I did this all through the first unit, well, you need math to get a job, and if you're going to go to Red River, you need to take math. Sure, I could make that argument. For some of you, it's more convincing than others. You've seen the actual data. You saw your career report, and it told you whether or not math was important. So I can't necessarily win that argument with you. Now, I could say, well, governments know math is super important. And not just Canada. If you went to the United States, if you went over to England, they realized that the modern economy, especially as you guys when you get to be my age, old like me, that math skills will be a huge part of getting a job at that age, more so than age now. And so governments realize we got to put money into making sure students know their math. And as a teacher, it's frustrating. Whenever I have a student say stuff like this to me, it's like being a salesman trying to sell someone like garbage, right? I'm just trying to pitch you something that you hate. Well, that's frustrating, right? So I don't want to look at it that way. I want to say, okay, we've already talked about this. Let's talk about math in terms of making it more realistic. I would argue that at more than any point in the world history, from the moment we crawled out of the primordial ooze as cave dwellers, that math is more important now than ever before. We live in a quantitative world. Quantitative means to put a number on things, right? Or to quantify something. The ability to put numbers on stuff is huge. I mean, how many of you guys have phones? You have to put a number to that. You use the technology. Technology has numbers associated with it. Numbers, it's all there. Now, most of that ability has nothing to do with what you do in math class, but it's still a numerical mathematical skill. 8 years ago, think back, you guys were in elementary school. You were those, I'm trying to look at you guys right now and thinking you were these cute, remember how little you were? You were just these little ankle biters going into elementary school. If your math teacher in elementary grade 1 said, what do you think about math, little Johnny? You probably wouldn't go, I hate math, this sucks, so I'm never going to do this in the real world. So somewhere between that age and now, some of you are making that statement, hate math, okay? So what happened? What happened between the cute little kid you were and now? Okay, I moved. All right, so let's think for a second. Why do I teach math? Why does anyone teach math? I would say there's 3 main reasons. One is the job thing, right? To get a job, you need the math. To go, if this was like, to go to Red River, to go to university, you need the math. You got to do it, okay? Let's pull that off the table. Second reason, you need it to survive in the real world. I mean, if you go out for dinner and you don't know how to calculate a tip, you don't know how to calculate money, if you're buying a car from someone and they're ripping you off and you have no idea, you're going to have a lot of trouble surviving in the real world without having some basic math facts. The third one, I think, is actually the most important. If this was phys ed class, and clearly it's not, looking at me, if I was a phys ed teacher, I would argue that phys ed is important to keep you healthy in your body, to make your body strong. I would argue that math keeps your mind strong. My grandmother is 96. Just this year, she was put into a care facility. She had been living in her own house till the age of 95. For 70-some years, she lived in one house. My grandfather's passed away, so she's been living alone in a house for for a long time. She's smart. She can still do it. But this is because she has to keep her brain active. We all do, or our brains They don't, just like a muscle, you don't work, it falls apart. And I would argue that math, not math class, but math is like working out your brain. To me, that's the most important reason why I teach math. Okay? All right. I've made the argument. I've done it with you guys before. You're probably sick of it. You're sick of me saying, okay, Wux, I get it. It's math. It's important. Let's move on. All right, let's move on. Numbers. Again, let's set the Wayback Time machine. Your little kids, when you first learned about having more of something was probably a good thing, is when you first learned about, say, candy. And you realize, hey, if I have more candy than my sister, I'm better than my sister. Having more of something is good. It's better than having less of something. And as you got older, you had to make sure, hey, wait a minute. You come back from Halloween. Did you get more candy than me? How would you figure that out? Well, you had to figure out a way to determine, do I have more candy than, say, my sister?
Count, weigh, measure.
Sure. All of those systems, count, weigh, measure, involve some way to put a number on the amount of candies you had. That was your first introduction to math. It wasn't in math class. It was an introduction to math, and you realized it was important, okay? The most easy way to do that would be to count it, right? You could, if you were, I don't know, if you were a smart kid using a scale with the candy, you could, but I guess that was your first introduction to numbers. And your first math teachers would have been your parents, okay? Your parents, as your first math teachers, would say things to you. Hey, little Johnny, you have 2 candies. If your sister gives you 2 more candies, how many candies are you going to have? And being the smart little Johnnies that you were, you probably went, I'm trying to do your voice as you, 4 candies, 4 candies. You'd have 4 candies. Your parents or your friends or whatever probably worked on that. Once they realized you could do that, they said, you know what? You got 2 pets. Hey, if we bought you 2 more pets, how many pets would we have? And you went, 4 pets. You were so excited. We're going to get 4. And then they didn't give you the 2 pets. But, yeah, well, you were the lucky one, right? So you went, okay, I can do the candies thing. I can do the pets thing. Eventually, your parents, your first math teachers, would stop giving you an example. They'd say, hey, little Johnny, what's 2 plus 2? Now, at this point, you don't have candy to candy. You don't have pet to pet. It's just 2. To what? You didn't care. You just said 4. You knew. This is what's called the leap of abstraction. You no longer need a thing to work with. You can just work with the actual numbers like they're a thing, what they're not. Show me 5 right now. No, but that's 5 fingers. Show me 5. Right, that's a symbol. In order for the 5 to mean something, you attach it to something, like fingers, candies, a symbol on a piece of paper. But the actual 5 is symbolic. It's an abstract concept. So what you did was you did a generalization. You now could do 2 plus 2. You didn't have to ask, to what? What to what? You didn't have to ask that question anymore because you made that leap of abstraction. Now, moving the timeline up. You went to school for the first time. You had your very first math class back in kindergarten. They didn't call it that back in kindergarten, but you did. And at that point, you started making more leaps. Abstract math became more relevant. Now they didn't, in kindergarten, they still did the maybe 2 candies, 2 candies. They made groups. But as you got into grade 2, 3, 4, 5, etc., stop making groups. Now it's just a 2 plus a 2. Then it got more abstract. Then it started being things like 2x minus 5x. And then it became things like 7x squared plus the square root of y. The math became, from where it was at the real world, became more and more and more abstract. At some point, you maybe couldn't make the leap anymore. You couldn't make that leap over the sort of abstract position to go, I just don't get it. That's the simple answers when you say, I don't get it. But that's what's happening is you're not making that connection between what's real and what's abstract. And this is what's going to prevent you from getting a math credit, is if you can't find a way to make that leap. Because the questions are going to come up like they did in the diagnostic, and you won't be able to answer them. And as a result, you won't get the credit. My job, help you make the leap, right? Help you to jump over, to make the leap of abstraction. Okay, now, to be honest, a lot of math teachers use the fact that math is so abstract to show off how smart they are. It's kind of I made this word, I don't know, is this a real word? Snootily. Does that make sense to you guys? Snootily. It means to be snooty or to be snotty, right? Have you ever had one of those teachers? I had tons of them when I was in school, who acted so smart. Like they could make a math problem that was so difficult that you'd never get it. I don't want to be that math teacher for you. I don't want to say real, because that sounds like I'm trying to be cool or something. That's not what I mean. What I mean is I want to make sure that I teach you a way that's simple, that you'll always be able to work with. It won't work necessarily with every single math problem, but it's going to get you enough of a simple guidance to get through problems. And that's the goal for today, is to keep it simple, to strip away all that fancy math words and come up with a way to make it sort of a little more real. Okay. By the way, this is also why a lot of students hate math, is they don't see that math has a real impact. They're like, I don't care what 2x is. I don't care, because I'm never going to care what 2x is. I get that. So we need to find a way to make it realistic for you. All right. All right, let's pull it together. Let's see what you guys know. From the diagnostic, you guys probably knew this. Numbers. Already, you guys shown that you know what the numbers are. Second thing you probably know, these symbols. These 4 basic ones. Okay, here, let me put them out for you. Here's the basic symbols you should know. So these 2, you might call them plus, take away. They mean addition, subtraction. Here's an example. 4 plus 5 is 9. 9 minus 5 is 4. I think you guys got that one. Your test showed you knew that one. Times or multiplication. That symbol, although that symbol was used through most, if not all, your elementary. As you got into middle school and now into high school, they're moving away from that one. They're making it more abstract again. They're using things like these. Right? Any of you guys seen this before? 4 and 5 in brackets. What does it mean? It means the same as that. Same as multiplication. That makes it more difficult maybe. Right away, you lost that connection there. So I'm not going to focus on that today, but that's something I want to rebuild with you guys so you understand that this and this mean the same thing. Divide, division. Same thing. Most of the time in elementary, you use that symbol, but when we do our unit on fractions, you again remember that fractions and division are essentially the same thing. You're dividing it up. And then today, what I want to focus on is this idea, negatives. I'm not going to re-explain negatives to you too much, a little bit, but I want to give you that simple way to work with negatives. All right, here it comes. Guys, settle down. I know. That's fine. Just be quiet talking. All right. So we're going to combine the basic math functions, the little addition, subtraction, multiplication, division, with the symbols, and prepare you to be successful. Okay? So let's lay down the goals. These are the goals for this course, my goals for you guys. The goals of numeracy. You've seen them before. Let me lay them down for you. Basically, I want to do these things for each thing we learn. 1, what's the words I'm using? What is the language? If you don't understand the language, you can't answer the question. 2, give you a method. Give you a way to get through to the answer. And I'm going to do that by stripping it down. Stripping it down to the basics of just what's the language, what's the method. You're going to hear this a lot from me all through the course. What's the language, what's the method? Okay? Here's how you be successful. Some of you might be missing number 1 already. Number 1, attend. If you don't come to numeracy, and I mean that both physically coming to numeracy and mentally coming to numeracy. If you guys show up here every day, and I don't say guys specifically, but if you show up here every day and don't listen to me, don't do anything, you might as well not actually come because you're not getting anything useful out of the course. You're just getting attendance. And attendance doesn't give you a credit. So when I say attend, I mean both physically and actually paying attention. 2, the language, make sure you understand the question. 3, practice. I wish there was another way, but the fact is I can show you how to do something once, that's not going to make it stick. You have to practice, okay? All right, so let me draw you a little animation for this. We want to get from a math question to a math answer. We want to get from a math problem to a math solution. That's the way you get marks in math. You get a worksheet, that you get questions, you got to put down answers. You get a final exam, you get questions, you got to write down answers. There's no other way in math. They don't mark you on your looks, and in some cases that's probably a good thing, okay? Nobody took an insult. I didn't say that to anyone in general. I meant for my other classes. You guys are gorgeous. You'd all get 100. You don't get marked on your attendance. You don't get marked on your dance skills. You should take dance class for that. In math, you get marked on questions and answers. That's it. So how do we get from A to B? As I just said, know what the question's asking and figure out what steps do I take to get to the answer. And then, like on the bottle of a shampoo, what's the last instruction on a bottle of shampoo? You girls probably know. It says, apply the shampoo, put it in, rinse, and repeat. Repeat the step. You know why they do that? Just so that you'll use up more shampoo. Yes. Yes. All right. That's the answer. All right. The repeating part is super important. If you don't repeat it, it's not going to make it easier for you. I wish there was another way. Okay? So when I give you the worksheet today, there's lots of questions. Why? Because you're repeating it. Why? So it helps you to learn it. Okay? If there was another way, I'd give you another way. There isn't. All right. What I'm going to do in this course is show you 1 and 2. You're going to have to do the 3. You're going to have to do the repeating part. I'm going to show you the 1 and the 2. I'm going to say, here's the type of language that this type of question uses, and here's the way to solve it. Period. I'm not going to give you 500 different ways. I'm going to give you a way to solve it. All right, let's take a look. You ready to start? Here's how we start. We're just going to start with brackets. What are brackets, and why do I even use them? Well, here's why. Brackets, also called parentheses or braces. I hate those words, so I'm going to just use brackets. But you might see that in another math class. They call it parentheses or braces. Are used to group things. There are generally 3 types. The round ones, the square ones, and what I call the curly ones. But you know what? Most of the time they use the round ones. More often than not, they just use the round ones. So let's just go with that. I'll strip away the other stuff. Let's just worry about the round ones. Yeah, what goes in there is math stuff. Okay? Brackets always come in a pair. So you always have an opening one and then a closing one. That makes sense. I don't think that's a big deal. What you put inside the brackets creates a package. Hear those words. What you put inside brackets creates a package. Remember those words. Okay? Because a package of math stuff helps you be organized. So the next example shows you why. Okay? I'll go through it quickly. So here's the question. 5 plus 4 minus 2. Okay? Couple steps there. So what I could do is I could do the 5 plus 4 first. I'd get 9. And then I'd take the 9 and subtract 2, and I'd get 7. That's the right answer. I do that first, then I do that second, but I'd have to do this part first and then do that second. Now if I did it the other way, what if I went 4 minus 2? If I did the back end first, I'd get 2. And 5 plus 2, I'd still get 7. So I'd get it right. So far, no need for brackets. No need for anything. I can do this. But what if I switch it up? What if instead of subtracting, I switched it to multiplication? Right there. Okay? Now I do the first part. 5 plus 4. I get 9 again. Then I do the second part. 9 times 2. I get 18. Okay? But now I go the other way. Now I do the back end first. So I do 4 times 2, I get 8. And then I add the 5. 5 plus 8, I get 13. Those are 2 completely different answers. Only one of them is correct. So one of the reasons we use brackets is to get organized. Because if I rewrite this and put the brackets there, what did I say brackets make? I said focus on the words. See, this is where you're not attending. Right away, 3 people not attending. Okay, let me go back. You're not attending. You're not doing this. You're not going to get, your mark will not get better. Your mark does not get better, you don't get the grade 9 credit. You don't get the grade 9 credit, you don't graduate. If that's what you want, there's the door. Go now. The result will be the same. That's what I'm saying to you. If you don't want to actually try to get better at math, you will not. And now when you retake the grade, now there's no chance you're getting a recovery credit in this course. So now you are absolutely doing grade 9 math again next year in grade 10. And transitional. This is what I'm saying. This is the consequence if you don't attend. And I mean physically and mentally. Okay? So, that was my warning. So now we're back here again. We're back. What did I say a bracket creates? A package. This creates a package. Now here's why I want you to think that way. It's a package of math stuff. Ready? Ready for this? Package. Okay, wait. See it again. Package. Yay, a package of math stuff. My dream has come true. Walks has given me a package full of math stuff. Now, why did I call it a package? What do you think of, and actually let's call it a present. I didn't want to use present because I thought that was even cheesier. When I say present, what do you think of instantly? Probably one of 2 things. No, what event do you think of instantly? Christmas and birthday. I want you to think of Christmas. When you were a little kid and you were given a present and it's Christmas morning, what was the first thing you wanted to do? Exactly. So when you get a package, when you get a present, you want to do that first. Absolutely the first thing you do. So when you get a package, think of it like Christmas morning. You can't wait to unwrap it like a little kid. You absolutely want to unwrap that present. You absolutely have to. You can't, you're so excited you can't do anything except think about the present. It's the first thing you do, which is important. Because in math, brackets means do this first. So if you think of brackets as a present, as a package, it's the first thing you do. That's later. We're not even getting there yet. Okay? So that's my point about brackets. So all I want you to take away from this is the following. Brackets are a package of math stuff. Isn't that awesome? I'm giving you the worst present you've ever gotten. Well, maybe not. All right. Now, we finished with negative numbers. You've seen them before, so I'm going to briefly reintroduce them to you. You started counting at 1 when you were a little kid, and you went up from there. You later learned about 0. 0 was the next thing you learned about. 0 to 0. Yeah, 0 to 0. Right? I doubt you learned about 0 before you started counting at 1. Even with the candies, you didn't go, I have 0 candies. No, you started with, I got 1 candy, right? 0 came in a little bit later, probably before school, or probably before you started kindergarten, you knew about 0. But it was then, once you got to school, that this number line all of a sudden went the other way. Probably around grade 3. And around grade 3, when you learned the number line went the other way, you learned there were these things called negative numbers. And for some of you, and it showed on your diagnostic, that's where you lost the leap. At that point, you could no longer get it, what this meant. Now, I'm sure some of you have seen a number line like this before, probably in elementary, probably in middle school. Okay? Essentially, negative numbers are the opposite of positive numbers. Okay, we'll move on from there. The number line is still super useful. In no way should you give it up as a tool. So for example, if I said, what's negative 5, add 2? You could use a number line and go, well, if I'm adding 2, I'm going to jump 2 spots forward, and it'll be negative 3. Yeah, you're right. So the number line works for that. But I wish I could tell you that when you do grade 9 math, this is the kind of question you're going to get. It's not. You're going to get more complex questions in this. They're going to make it more abstract. I'll show you. I'm going to show you the types of questions you're going to get. So we need a new method. This is okay, but I want to give you a new one. Okay? No. All right. So if you take all the positive numbers and you take all the negative numbers and you take 0, there's a name for that, a fancy math name. It's called integers. Again, you've probably heard that before. I don't care. You can learn that again when you do grade 9 math again. Integers. We use the negative symbol to indicate that a number is negative. We could use a positive symbol to indicate a positive number, but math teachers are lazy. So they just go, you know what, I don't want to write the positive. It's too much work. So if you don't see a negative, it's positive. That's what they do. It's just that simple. They're just lazy. Okay? If there is no sign, we should assume someone was lazy and it's positive. Okay? So sometimes this gets confusing. We have positive numbers, we have negative numbers. Here's where the brackets come in. The brackets are used to help create a package to help avoid the confusion. So I'm going to show you the examples of this. Here I'm going to show you the 4 basic math functions, addition, subtraction, multiplication, and division, using negatives, using brackets, and let's see how you guys do with these questions. All right, let's try the first one. Negative 5 plus 5. Well, we just saw that on the number line, so that's not too bad. I think I could probably do that. I don't want you to necessarily do it, but you could probably do it. I mean, Solis, you just did it, so it's not that bad. Got it. Right? No one in here is probably struggling too much. Now, this one.
Negative 10.
A minus, a negative, minus a positive. Yeah, you might be able to get that one. It's not too bad. Some of you might be confused. At this point, some of you might be able to leap from 1 to 2. Can't quite get there yet. Now let's go to 3. A negative plus a negative. Okay, that's getting a little harder. Maybe. Maybe that's a little bit harder. Is it 0? Is it 10? Is it negative 10? Okay, it's getting a little harder. How about number 4? Negative 5 minus, negative 5 minus negative 5. A negative minus a negative. What? What? Some of you might not be able to get that one. Let's go another step. How about negative 5 times 5? Okay, I give up. Times, too much. How about negative 5 times negative 5? I hate you. That's awful. I don't know what to do with that one. How about negative 5 divided by 5? Okay, I'm done. Dividing, forget it. And negative 5 divided by negative 5, I'm out. I'm out. This is maybe where you guys were when you did that diagnostic is, you know what? I give up. I'm done at this point. These are the kinds of questions you can expect. So, first thing is, do you understand the wording of the question? Do you understand what it's saying? But then the second part, which is super important, is, do you have a method? Okay? Now, that's what I was just saying. Do we know what the question's asking, and do we have a method? So, I hope you know what it's asking. You know what a negative is. It's the opposite of a positive. You know what brackets are. It's a package, right? It's a package of math stuff. So now what I want to teach you is a method. Now, what I don't want to do is go through all these different scenarios and go, well, here's how you do this type of question. Now, here's how you do all 8 different. No. What did I say I was going to do in this course? Strip it down simple.
Give us 1.
1, right. 1 or 2. So first of all, what's the one thing I said about brackets? What's the one thing? Someone knows. You're not attending.
Do it first.
What's a bracket? No, what is a bracket? What? No, yeah, but what's the stuff in? Package or present. It's a present or a package of stuff. A bracket is a package. Here's what I want you to know about negatives. It's a memorization technique. Do you guys know about memorizing things? Do any of you guys date? And no one in here dates? Okay, so here's some dating tips. I know you're getting them from the 45-year-old guy who looks like he's never had a date in his life. I have 2 children, so I got a date once. When you meet someone, say at a club, that was my club dance, and they give you their phone number, and you need to remember it because this is someone you'd like to have a date with. How do you do that? Say you don't have a pen. Say you don't have your phone. You have nothing. All you have is your brain. How are you going to remember it? Say it over and over again? And over and over and over and over and over again? That's a great way.
I would not remember.
That's a problem, right? So my wife has a degree in psychology, and she described this to me once as a mnemonic, isn't that a fancy word? Actually, mnemonic memory device. isn't. It's a psychology word. It means a way to train your brain using a trick to remember stuff. The simplest mnemonic memory device is exactly what John said. Say it over and over again. But you know what? What's actually easier than that? This has actually been proven to be true. When you meet someone, forget the phone number. You meet someone at a club and they introduce themselves to you. 5 minutes later, will you remember their name?
No.
Because ladies, back me up. If you meet a guy and you tell them your name and then 5 minutes later they don't remember who you are, are you more likely to go on a date with them or less likely? Yeah. They don't remember your name. That's probably a bit of a diss, right? Here's an actual thing that has been proven to work. When someone says to you, "Hi, my name is Sarah," if you repeat it back to them and say, "Hi, Sarah, nice to meet you, Sarah," the chances of you remembering their name just went up by like 60%. By you actually saying it out loud, you really remember it better. Because most of us don't. We just go, "Oh, hi, nice to meet you."
Hi, person.
Yeah, or something like that. But if you actually say, "It's nice to meet you, Sarah," and say their name back, you will most likely remember it. I want you guys to try this. Right now, we'll test it tomorrow. I want you to actually say out loud. Imagine I'm Sarah. Say, "Hi, Sarah. Nice to meet you, Sarah." Out loud. It doesn't help if you just do it in your brain. Say it out loud right now. "Hi, I'm Sarah."
I'm not Sarah.
Hi, I'm Sarah. Hi.
How's it going, Sarah?
Okay, so tomorrow, Friday, we'll test that to see if you guys remembered the name I had today. Okay, so here's what I want you to remember about negatives. One sentence. But I want you to say this sentence out loud. And the out loud is important. Because it'll help you remember it, just like Sarah. Who? Sarah. Yeah, Sarah. Here's the sentence. And again, attend. A negative and a negative is a positive. That's it. Say it 7 times. Out loud. Here, let's all do it together. Come on. Let's be fun about this. Everybody stand on a chair or something. Or do something silly like this. Yeah, come on, let's do this. Okay, don't fall. Then just stand. Come on, you can do this, Torres. Yes, you can go to the bathroom. Okay, let's do this. Ready? Out loud. Let's be loud. Let's bug other classes. Okay, wait, we'll do it together. Okay? Ready? We're going to do it just once. Out loud. Ready? 1, 2, 3. A negative and a negative. Positive. Okay. We don't want the principal down here. That was pretty good. Maybe that's definitely going on the mic. Okay, this time, not loud. Not loud. I know, I did. So I'm changing it. For our second turn, look at poor Molly. She's like, "What is going on?" All right, here. Second time. I want you to say it in a German accent. I don't care if you know German, but pretend, like Arnold Schwarzenegger. I'm Arnold. So like that.
I can't do German.
I don't care. Do an accent then, okay? Doesn't matter. Just say it silly. Say it silly then. Ready? Second time. Ready? 1, 2, 3. A negative and a negative is a positive. Very good. Okay. Now, the next, you can get down. Whoa, I'm almost killed myself there. Okay. I want you to do it 5 more times. We'll count up together. Whoa, slow it all together. This one, just normal. Just say it normal. Ready? 1, a negative and a negative is a positive. 2, a negative and a negative is a positive. 3, a negative and a negative is a positive. 4, a negative and a negative is a positive. 5, a negative and a negative is a positive. Great work. Okay? I hope you remember. I hope a year from now you're sitting down for a math test and you have a question like one of these. And you'd be like, or this one, and you'd be like, I wonder what I should do. And you go, hey, wait a minute, a negative and a negative is a positive. So let me show you how it actually works. So if that's true, what does this mean? Well, we get a question like this. 5 minus negative 5. So what can we do? Let's rewrite it. What do we write it as? Well, a negative and a negative becomes positive. So we write it as 5 plus 5 equals 10. We're done. Now, we get a question like this one. Negative 2 times negative 2. What do we know? A negative and a negative is a? So 2 times 2 is 4. Positive. We do a division question. Negative 2 divided by negative 2. Negative and a negative, positive. The one thing you need to know. Let's summarize the day. The takeaway. Language, brackets. Brackets are packages. That's all you need to know. Negatives are the opposite of positives. That's all you need to know. And what's your method? A negative and a negative is a positive. That's all you need to know.
Negative and a negative.
Atta girl.